In this example from Chapter 9 of the Introduction to Practice of Statistics, 8th edition by Moore, McCabe, and Craig, we're going to look at comparing several populations using a chi-square test and using the functions in Excel to perform this analysis. We have data looking at cell phone only households and households with a landline and their political party affiliations: Democratic, refuse to lean either way, and Republican. And what we want to test in this, our null hypothesis, is there's no difference in the distribution of party affiliation in the cell phone only and the landline populations. So the information that we're given, our actual or our observed data, is that our cell phone only households, we have 49 who are Democrat, 15 who refuse to lean either way, 32 Republican households, for a total of 96 households in the cell phone only category. In the landline category, we have 47 Democratic households, 27 who refuse to lean either way, and 30 Republican households, for a total of 104 households in the landline category, equaling a total of 200 total households. We need to generate our expected counts table now, and so we can use the row and the column totals for this. So if we multiply our first row total and column total and then divide by our overall total, we come up with an expected value of 46.08 Democrats in the cell only category. For this cell, we can use absolute referencing in Excel. We want our row totals to remain in column I and our column totals to remain in row 7. So we'll put dollar signs in those respective places, and we don't want our total to change locations. So we put that on each side of the I and the 7, and now we can drag this formula through our table to come up with the rest of our expected values. So now we have our observed values and our expected counts, and now we can do our chi-square calculations. So we need to take the difference between our observed and expected counts. We're going to square that difference and then divide by the expected values, and we can drag this through our table. And now we come up with our chi-square statistic for each cell. We can sum this chi-square, these individual chi-square statistics, to come up with our overall chi-square value. And this value of 3.22, you could use a lookup table to determine the p-value based on the appropriate degrees of freedom. So the degrees of freedom are the number of rows minus 1 multiplied by the number of columns minus 1. So we have 2 degrees of freedom. We can also use the Excel function to find the p-value, which is CHISQ, so chi-square.test. And we just select our actual range, or our observed data, separate it with a comma, and then select the expected values, and we get a p-value of almost 0.2. With this p-value, we're going to fail to reject the null hypothesis, meaning that there's not enough evidence to conclude that the distribution of party affiliation differs in these two populations.